Subject name Compiler Design, 3rd year CSBS, 5th semester, Unit 4. Topic is Intermediate Code Generation, Unit 4. Intermediate code generator receives input from its predecessor phase and semantic analyzer phase. Using the intermediate code, the second phase of the compiler synthesis phase is changed according to the target machine. Translation of different language features. Translator is a computer program that translates program written in a given programming language into the functionally equivalent program in a different language. Depends upon the translator, this may involve change or simplifying the program flow. The translator should not losing the essence of the program. Types of language translator. There are 3 types: assembler, compiler and interpreter. Assembler translates assembly language into machine language. Compiler will translate code written in a high-level language into low-level language, object or machine code. Interpreter, which is executes other programs directly, running through the program code and executing it line by line. Different types of intermediate forms. One is a high-level intermediate code, the another is a low-level intermediate code. High-level intermediate code can be represented as source code. To enhance performance of source code, we can easily apply code modifications, but to optimize a target machine, it is less preferred. Whereas in the low-level intermediate code, which is very close to the target machine, which is suitable for register and memory allocation and also machine-dependent optimizations. Intermediate representations. There are 2 kinds of intermediate representations are there. First one is a tree and the linear representation. A tree, which is parse tree and syntax tree. A linear representation is a 3 address code. Intermediate representations of tree, parse tree and the syntax tree. Parse tree is a graphical representation of the replacement process in the derivation. Parse tree in each interior node represents a grammar rule, which has each leaf node represents the terminal symbols. And then parse tree provide every characteristics information from the real syntax. And then parse tree is a less dense than syntax trees. Syntax trees, which is compact form of the parse tree, which is derived from the parse tree. Each interior node represents as operator. Each leaf node represents an operand. And then syntax tree do not provide every characteristic information from the real syntax. And syntax tree more dense than parse trees. 3 address code. The 3 address code is also the form of intermediate representation like a syntax tree. The parser generates a syntax tree. The intermediate code generates the 3 address code. This intermediate representation is a sequence of assembly-like instructions. 3 address code. In the 3 address code, 3 operands per instruction is given and each operand act like a register. Instruction must have at least 1 operand on the right hand side of the instruction. If you want to hold the values computed by the 3 address code instruction, the compiler generates the temporary name. The 3 address instruction may have less than 3 operands. The 3 address instruction is in the form of X, which is equivalent to Y, OP, Z. Y and Z are operands. OP is an operator. X can be the name or the compiler generated temporarily name, that is location where we are storing. That is the values hold the result. The 3 address instructions are always executed sequentially. They can even perform the conditional or unconditional jump. Thank you.